You could find the absolute cheapest, the ones that are going to arrive at your doorstep the fastest. And no, you know, for those types of purchases, you care about the quality and you want something that works well for you, and you're willing to, you know, pay more rather than the cheapest. For other things, you know, absolutely, even in clothing, there are lots of things that are commodities, and you should totally go to Amazon for that. Right? Cool. I guess this was interesting, but I'll talk about DevOps in a moment if you're interested. Cool. Anyway, so we apply intelligence to those recommendations, but everywhere. And I guess I'll go, oh, and the other aspect, like as humans and machines, you know, each making each other better. So who plays chess? Yeah, probably a lot of us, great. So we know, people have heard of freestyle chess. So we all know that Kasparov was beaten by Deep Blue, you know, whatever, 20 years ago. What you, I hope, also know is that the current best chess playing unit is not a human or a machine. It's a human augmented by a machine. Right? So Kasparov now, when he plays, loves to play with a machine. So the machine calculates all the, you know, all the probabilities, and he can be the creative human that he is. Yeah. Can I provide a citation for that? Maybe later. Sure. Not in this deck. Okay. Cool. Anyway, so I kind of said all these words, but from the client's perspective, we have a bunch of inventory. We send you a box, you open it, hopefully you like it. Behind that line is a bunch of machine learning, a bunch of models that compute size, style, price preference, etc. We sort of ensemble them all together, you know, a la Netflix recommendations, and make a set of scores. Again, so, you know, every piece of inventory is sort of scored times every one of our customers every day. And then those algorithmic recommendations go to an actual human, and the humans do what the humans are good at, like they put together an outfit, or which the machines aren't good at yet, right? The machines are good at predicting the individual things, what you might like, but they're not very good at putting an outfit together. Also, you know, you can make a request like, I'm going to an evening wedding in New York. Give me something appropriate. The machine can't do anything with that, but the human immediately knows, okay, slinky black dress, or, you know, whatever, right? Does that make sense? Cool. Okay, so now we're going to talk about DevOps. So how do we work? Also, how does Amazon work? How does Netflix work? How does Google work? And why does that way of working work? So I'm going to talk about 3 of these elements, but there are 4. I think modern software development comprises organization, it comprises our processes and practices, it comprises culture, and it comprises technology. I'm going to talk about the first 3, and we can talk about technology another time or in questions or whatever, but I wasn't planning on covering that. What are my, just super briefly, if you took nothing away from, you know, what I say here, organization, I believe that we should build even large organizations out of small teams that have well-defined areas of responsibility. In terms of, since we're building software, in terms of processes and practices, I believe strongly in test-driven development and in continuous delivery. In terms of culture, I believe in sort of DevOps and learning and so on, which we'll talk about as well. And then certainly beyond a certain scale, the scale that we're at, or Amazon, or Google, or eBay, I believe in microservices as a technology approach. But we won't talk about that today. Okay, so first I want to talk about small teams. So has anybody heard of Conway's Law? Great, lots of people. Okay, so Mel Conway in 1968 posited this idea, essentially that your organization determines your software architecture, or more precisely, the design of a system is going to be the reflection of the communication paths within your organization. And Eric Raymond famously quipped, okay, well what that means is if you have 4 teams building a compiler, you're going to build a 4-pass compiler, right? But we can, and Mel Conway meant this as a descriptive law, like he meant this as describing what he saw, but we can actually use it in a normative way, so we can use it to our advantage. So in particular, if we want to build a modular system, like we want to build a large system architecture, we like to build it out of smaller components. If we want to build a modular system, it really helps us if we have a modular organization. So we'll talk a little bit more about this, but small independent teams are going to lead to more flexible, more composable systems. And larger interdependent teams are going to end up leading to larger, more monolithic systems. And so again, we can use this in a normative way to our advantage. So we can engineer the system that we want by engineering the organization. Does the concept at least make sense? Yeah, cool. Okay, so this is the way that Amazon works, Google works, Netflix works, and also Stitch Fix. So you probably heard this term of a two-pizza team. So this is, I think it's actually credited to Jeff Bezos himself. The idea is that no individual team should be larger than can be fed by 2 large pizzas. Typically, that means there are 4 to 6 people. What I love about there's a corollary that my friends at Amazon like to say, which is that actually means you can't have too many junior people because they eat a lot of pizza. Does it make sense? Right? So, you have to kind of limit, you have to have a mix of, junior or senior, like mix of people that, eat a lot versus, don't eat so much. Those service teams ought to be aligned to particular business domains. So, a team would have a well-defined area of responsibility. If you're building, as I would recommend, a sort of service-oriented architecture, a team might be responsible for a single, large service or maybe a set of related smaller services or applications. And just like a good service, that team would kind of have a well-defined interface to the rest of the company. So here's the way that you should, talk to this team. Here's the way you should interact with us, et cetera. It's a good example of, in the same way as we build large software systems out of small independent components, building a large-scale software organization out of small independent components is a great way to do it. And it's this technique or this approach that has allowed, in my opinion, Google and Amazon to be really fast moving, even though as they get bigger and bigger. Does it make sense? Like Google has 15,000 software engineers. And the reason why Google is able to be as innovative as it is because it does not operate as a 15,000 person organization. It operates like 3,000 5-person organizations. And ditto Amazon, ditto Netflix, ditto a bunch of other companies. Yeah. Yeah, to be honest, I'm not super religious about the exact number, but when you get to 8 or 10, yeah, typically, in practice what I've seen is a team of 8 or 10 almost naturally subdivides into smaller things anyway. So if it's an application, for example, maybe there's a natural subdivision around the front end versus the back end, or there's a natural subdivision between this particular vertical part of the application and this other part, like maybe, I'm making this up, but one part is the consumer facing and the other part is the administrator facing, something like that. That's just been my experience. The largest sub-team, so when I ran engineering for Google App Engine, we had 100 people in the team, overall. The largest sub-team we had was 6. So, yeah, sure.
And I noticed that when you pull it below 6, it's the same thing, saying all the people on the team belong to the same clique.
They belong to the same clique? I guess I'm not sure what you're implying with that, but they're all on the same team, so they all should be working together for one common goal as opposed to conflicting goals. Is that what you're implying? Yeah, that's a good insight. So just since I'm not repeating the question, sorry, I know you can hear it in the room, but the observation was that larger than 7 or 8 people in a boardroom example, like it subdivides into several cliques. And actually, that kind of, that probably parallels your actual experience. Like imagine a dinner party where like it's 6 people, that's one conversation, but as soon as it becomes like 8 or 10 people, that's 2 conversations, isn't it? That's been my experience. So yeah, cool. Okay, so another aspect, so let's make those teams small in a well-defined area of responsibility, and let's also make them full stack, or maybe cross-functional would be another word for that. So what I like to do with teams that I run is make sure that a team has all the disciplines within that team boundary to do that team's function. So that team's function is going to include some design aspects, some sort of development, hopefully, quality, performance, maintaining the things that they build, operating the things that they build. So all those different disciplines. Now, you can imagine that you don't have one person for each of these, that multiple of these roles are played by each person, or maybe everybody plays all those roles. But you want to draw those team boundaries in a way that a team can be mostly autonomous, right? And so then The analogy I like to use is think of building a team not as a factory, but as a symphony, right? So a factory is where everything's going to be the same. But think more of building a symphony, right? So I want to compose pun not intended. I want to compose my team out of, okay, I have percussion, and I have woodwinds, and I have strings, and I have brass, right? And it's not about having all brass or all percussion. It's about a mixture of those skill sets all working together. Maybe another analogy would be a rock band, right? So there are a few bands you can think of that are all guitars, but mostly it's, okay, drums and guitar and a singer, and you see where I'm going. And what I don't want to imply is that a team does everything in life. Like at Stitch Fix, we don't do our own chips, we don't build our own operating systems. Google does those things, but they don't have a team where one team boundary is building the chipset and also deploying them to the data centers and also writing the operating system, right? So those are different other teams that offer those services or libraries or whatever to other teams. And so you end up having this sort of, if you're large like Google or Amazon, you end up having this sort of a graph of teams that do supporting services at the bottom, and then other things are built on top of that, et cetera, et cetera. Does that kind of make sense? Cool. Okay. So another aspect which sort of related is, I'd like teams to have sort of end-to-end ownership of the things that they build. So teams within the constraints of what the business is trying to achieve, teams are given a goal, but then sort of own the roadmap in order to achieve that goal. I do not like to have a team that builds the cool stuff and then another team that gets the terrible work, right? So a team that builds the new things and then a maintenance or sustaining engineering team that maintains the other stuff. When there are things that we have to maintain, because like legacy just means it's something that actually works and runs the business. So every business, no matter how old they are, has such a thing. I like to have the maintenance of stuff that we have built and is running before also be part of a team that's building new things. Does that make sense? And then one nice property is to have teams be long-term, right? So, and that's why being aligned to a business domain is such a nice thing. So in the example of Stitch Fix, for example, I have a team that builds software for the merchandising team that buys the clothes, and I have a team that builds software for those stylists, right? And I have a team that builds the software, actually several teams that build different parts of the software for our warehouses. So, choosing the shipping carriers and pick the application that the pickers use to pick those 5 items in the warehouse, et cetera, et cetera. Yeah?
I guess define long term in the value you said, and I wonder if you've been with the same company for 22 years.
Yeah, so it's not long term. I mean, you say, yeah, long term, 22 years, yeah. I have not been at a company for 22 years. My best I've done is 7. But long term in the sense of a business, right? So a team is going to build a piece of software or own a particular area for a while. And I guess what I'm contrasting it to, I guess I'm not contrasting 22 years versus 2 years. I'm contrasting 2 years or more, let's say, versus a project-oriented team where you bring people together to do one thing and then they disperse again. That's sort of more what I'm contrasting. But thank you for keeping me honest about that one. Yes, sir. So let's see, you're suggesting that if I have larger teams, I will have more
So a team of 12, like a sitting around the table, that's one conversation. But I've got 1/4 of the inter-team communication problems I would in a larger organization. And that's why I have a team of 6.
You have 1/4 of the
inter-team relationships are n squared, n times n minus 1.
Every relationship is n squared, yeah. Every relationship, whether it's within a team or between teams, is n squared. Completely agree. So let me try to answer that. So I left these slides out, so sorry. There's a wonderful generalization of Amdahl's law called the universal scalability law, which people are familiar with Amdahl's law, parallel speedup, right? So that is, that talks about one aspect of scalability, which is a bottleneck or a lock. So you contend on a shared resource. That is order n, right? So there's one door to get out of here. To get, if we double the number of people in the audience, it takes us twice as much time to get out. Does that make sense? There is another aspect. So the generalization of Amdahl's law was formulated by this guy, Neil Gunther, who was a long time, still is, well, used to be at Sun and still is a long time excellent performance analyst, Neil Gunther. And so he formulates this idea of the universal scalability law. The other term is what he calls contention. I call it coordination. And that's kind of what you're talking about, where there is an n squared term where everybody needs to talk with everybody else. So examples are, imagine a code review process where every code review submission needs to be reviewed by everybody else in the group, right? I hope we do code review, we certainly do, but we don't have it reviewed by everybody, we have it reviewed by maybe one or two other people, right? So that scales. But if every submission is reviewed by everybody, now that's n squared, right? So you can see that if I double the size of the team, now I have quadruple the amount of code reviews that are happening. Anyway, so what you were suggesting was that conversations are n squared. Agreed. So what I suggest is two things. I suggest making teams small so you have really high bandwidth